speaker. Next up, we have James Wells, who's the interim CEO and Chief Commercial Officer at Sanctuary AI. He was very recently appointed, so we're very lucky to have him talking with us today. And Sanctuary, I think I've been writing about for a while, and I think that they realize, maybe earlier than almost anyone else, just the value of data, as we've been talking about a lot this afternoon. And so they've been having humans in the loop, collecting data for their robots for, I think, maybe longer than anyone else. And I'm very curious about how they are going to leverage that to get robots that can have like a general purpose, human level performance, as I think that they put it, which is very optimistic and ambitious. So I'm looking forward to hearing more. Let's welcome James.
Thank you. Good afternoon, everyone. My name is James Wells, as I was just introduced, and I was appointed CEO about 30 days ago. And the first thing I did as CEO is I called engineering and I said, make the robot taller. I didn't. I actually brought my kids to the lab. They hadn't been there for a while. So I was the 6th employee, and we started this company in 2018 with a very ambitious mission statement, which is to build human-like intelligence in general purpose robots. And I remember those first sales calls where people were asking me what that actually meant. So every presentation I always start with the same way, which is defining what that actually means. So for this crowd, this is probably fairly obvious, but our definition for intelligence is the ability to achieve goals. And I'm going to go on a risk here and try and define artificial and general intelligence, which is a system that can achieve any goal in any embodiment, in any environment. And that starts to get pretty nonsensical if you start thinking about all the combinations. So we had to constrain the mission statement to human-like intelligence, which is achieving human-like goals, which is generally what humans do in exchange for money, in a human-like embodiment, which isn't necessarily a humanoid, but it's a mobile, a bimanual, dexterous machine in any human-like environment. And of course, that speaks to the trillions of infrastructure that humans have built for ourselves to carry out work. So if we are successful in achieving our mission, we're addressing one of the largest capital flows in the world. So almost 30 to 40 trillion annually flows from employers to employees. And that is the goal of the company, and I've indicated we are located in Vancouver, Canada. Okay, there's a lot to talk about. I've got 15 minutes. I was going to focus on something that is quite unique to us, which is dexterity. So I agree with the folks at Tesla here, where half the engineering of Optimus goes into the hand. We built 9 generations of hand. We've tried to build cable-based hands, pneumatic hands, actuated in-hand hands, and the challenge we see is the industry is largely stuck in this paradigm of low power density. And so when you compare the power density of electromechanical actuation with the human hand, it's not even close. And so we started thinking about 3 years ago, how can we actually have a shot at achieving human level dexterity? And so we've been pioneering this approach using hydraulics. So I'm going to show you some oldie but goodie videos here. The early days where we showed you could get millimeter precision. So here we are peeling a bunch of labels. This is at our first deploy. And you can see some of the hydraulic cabling there. And then this is a soldering video, again, doing bimanual sub-millimeter precision, where we are soldering a wire. And so it really comes down to power density. So this is a plot where we compare the vertical power grip of hands over degrees of freedom. And what you see is as you increase the degrees of freedom, which you could argue is a proxy for capability, you lose strength, you lose power if you're doing electromechanical actuation. Except that's not true with hydraulics. So hydraulics is a pathway that we believe we can actually achieve human level dexterity. The challenge, of course, is there's a lot of engineering problems with hydraulics. So they can leak, they're generally at high pressure, there's no off-the-shelf components, and they're huge and don't actually fit into the humanoid form factor, and very low flow resolution, which means it can't really talk effectively to the other parts of the robot. So the big breakthrough we've had this past year is to miniaturize the valve and actuators to enable hydraulic actuation in a tight form factor in a humanoid. So here you see our valves and how we can gang them together to actually go in the forearm. So for every degree of freedom, you need one of these valves. And it's pretty amazing what the results have been. So the pressure in the system is no more than the pressure in a hydraulic bike brake. It's very low power. We actually just hit a milestone where we did 2 billion cycles on the actuator without any leakage or failure. And this system's been running on a robot for about 20 months, and we've seen about 1 million cycles on the valves with, again, no leakage or failure. And we compared it to off-the-shelf, which is a little unfair because off-the-shelf hydraulic valves would never make sense in this particular application, but we drove down the cost and increased the flow rate. Okay, I'm going to show a couple videos here. Turn my phone off, that's a good idea. I was the CEO of another humanoid company. Oh, sorry. Come on, Betsy. Okay, we're gonna skip that one. Every hand video needs an egg video. So here we're showing that we can crush an egg, but also not crush an egg because you have force estimation within the hydraulic fingers. This is a video we just released. Oh, come on, let's go. There we go. Just demonstrating in-hand manipulation. This is a 19 DOF system. Almost ubiquitous across a lot of the customers we interact with. They are looking for systems that can chaotically or blindly pick a part, reorient that part for then an insertion task. And so in-hand reorientation is a big focus of what we're doing. This is a 4 DOF thumb that's adjusting a wrench. This is a video we just released today where what I was saying, you have to pick an object in one grasp pipe, reorient it, and then insert it back into a fixture. Okay, 19 DOFs isn't enough. So touch is a really important aspect, and about 18 months ago we partnered with one of the leading haptics experts in the world, and this is hot off the press here. So this is our next generation finger. It's a 3 DOF finger with a white haptic sensor on there. When I was playing this video, my son walked in and said, "I thought you were building humanoids. Why are you building a brontosaurus?" I was like, yeah, fair point. Kind of looks like that. Okay, so that's the next gen finger. Now I'm going to show you some tactile feedback here. Very sensitive. So it's about 5 millinewtons in sensitivity. There's 7 air pockets, and it's extremely responsive to just a paintbrush. It's like the brontosaurus is smelling something. It's like, oh, I don't want that. Stay away. Okay, we'll stop torturing it. And this is something you can try and do at home and see how well you do. So when it touches the domino, it stops. Okay, the other defining feature of Sanctuary is our intellectual property portfolio. So we got going in 2018 with some very visionary founders and basically mapped out a 10-year road of how we would actually achieve the goal and started filing IP in each of those major activity streams. And so sort of as a side effect, we find ourselves here being ranked quite favorably amongst the community. So in terms of patent volume, we have the most patents out of any startup, but we're right up there with some of the name brands in the category of general purpose robot or dexterous manipulation. It's pretty cool to see we're ahead of NVIDIA, Microsoft, in this area. So the key categories is hardware, software for dexterous manipulation, how you can collect data and train, how you can evaluate and deploy models, and then managing fleets. And so some of the key patent families are around using LLMs and robotic control, how you use visual servoing or haptic servoing, model training with teleop. We've been doing teleop for since 2018 and patented a lot of the techniques there. And then, as I mentioned before, we build all kinds of hands and have continued to innovate and patent all kinds of those actuation mechanisms. On the AI side, I'm not going to show any demos, but I just want to bring focus to a really big challenge that people have been talking about, and it's how we get the last 20% of policy performance. So all this imitation learning, behavioral cloning gets you to policy performance of 80 to 85%, but the real trick here to unlock this industrial end-to-end models is to get to that 95, 96, 99%. And so we've been experimenting quite a bit with blending that with reinforcement learning and online RL. And I'm not sure if you can see this, but here's just a data point on a very complex pick task where we've managed to use RL to kind of achieve some of those I'd say commercially relevant performance levels. And that's where our AI is really focused on, is how can we fine tune it to get to a level where we can actually start to get bankable POs. So the mission still remains. When I take a step back and sort of evaluate the differentiated value that Sanctuary brings to the table, we've got this hydraulic hand technology, we've got this AI platform and this IP portfolio, and we're opening up to different partners to utilize our hands. We're opening up some of our intellectual property and actuator technology to share with the community. It's applicable not just on humanoids, but also non-humanoids, all in service of kind of feeding the business needs of the enterprise. So just to quickly summarize, we're about 150 people. We're based in Vancouver. We're going to hit 4 million revenue this year. We've got 3 go-to-market customers and partnered with folks like Magna, NVIDIA, and Microsoft. Okay, there we go. Time for questions? Yeah? Yes, sir.
You said 2 billion cycles. Was it for a single human actuator?
Yeah. It's a piezoelectric actuator that you can vibrate quite rapidly, so that's how we could get the cycles up so big. Yeah.
Share with us some lessons learned from your work with Ag.
Yeah, so Magna's been an investor for almost 3 years now. And Magna's interesting because they're Canadian, and the Canadian government cares about scaling the automotive industry. And so when you look at some of our components and components in EVs, it's kind of a natural partnership. And so if you're following the automotive industry, they're struggling a little bit. There's lots of layoffs. And so we are that new product opportunity for them. But they're still a car company, right? So the interesting part here is I'm like, look, just do what Tesla's doing and run the same program. But they're not orchestrated, or I'd say have an innovation mindset that's comparable to what we're seeing at Tesla. So a lot of these folks are really trying to, at least the C-suite and the senior leaders are really trying to pivot and grow the businesses in new growth areas. But it's a 60-year-old legacy automotive group. So there's definitely a spectrum of automotive manufacturers and suppliers that respond differently. But they're as much a scaling partner as a capital enabler as well to access some Canadian dollar government. Yeah. At the back.
How much of the revenue is deployment rate?
Sorry, one more time.
What percentage of the revenue is based on deployments?
Is based on deployments. So it's all proof of concept data or pilot capital. So we've got a graduated way we run a process that we run clients through. And you know, the product scaling revenue comes when you hit commercial KPIs, and that's generally a function of speed, quality, and availability. And you know, I'd say other than agility, a lot of folks aren't quite there yet, and that's kind of the metrics we're working towards. But it's all, I'd say, pre-commercial revenue. Okay, hearing none. Keep your eyes peeled for that tall robot.